So good news, you can back up your SQL Server databases. I've said it several times, I'll say it again. Part of security is making sure the data is safe. So having a backup gives you the ability to recover from disaster situations where all data is lost, but it also gives you the ability to time travel so you can undo unintentional mistakes. Some application runs rampant and deletes a whole bunch of files or a bunch of records. Programmer makes a new application and it's completely wrong. The things we can back up include a variety of things. So you can back up the database itself. Recall yesterday's conversation about transaction logs, how when you are changing or when an application is changing the SQL database, it doesn't directly touch the database file. All the required changes like add a record, change a field, that stuff all gets queued up in a transaction log, and the transaction logs get processed in a timely fashion by the SQL database engine. So therefore, you have the option of backing up the database and the transaction logs, or just the transaction logs. One of the advantages of having the transaction logs backed up is that in the event you are being really diligent and you're doing backups of the database on a regular basis, if suddenly the media gets corrupted and all you've got is a really old full backup, but you have all the transaction logs for the whole year, you can apply all the transaction logs to that really old friggin' backup and get things current in time. Yesterday's conversation talked about recovery time objectives, how fast you need to restore the database, recovery point objectives, at what point in time do you need the database to be restored to. Again, the scenario, if all the transactions on Thursday were crap and you want them eliminated, if you have the transaction logs backed up, you could use those to unwind, back out those changes. So it's all handy. If we have the backups, how do we manage them, right? So the media that it goes to, am I backing up to the cloud? Am I backing up to a file server? What file am I actually backing it up to? Am I putting all my backups in the same file so this file grows incrementally? Am I creating separate backups? So how to manage all that. Also, part of the management is double checking your backups. There are things worse than this, but going to your backup and trying to restore it and finding out that your backup is incomplete or corrupted or not what you thought it was, that's really bad. So part of the managing is double checking and verifying the status of your backups. And then some advanced things that you can do. Oh, hang on a second. Did I share this? Probably not. Meanwhile, back at the Zoom. Share. PowerPoint. Share. Yeah. Hey, it's just like class, eh? Like those times that I forget to turn a monitor on or switch the source, right? So there we go. Everybody see my PowerPoints now?
Yeah.
Okay, great.
Yeah.
Okay, so luckily I've realized I did that before I get too far in there. Okay. All right, so we're gonna have an intro to it. So doing the overall backups, media sets and backup sets. If you find this terminology confusing, you're not alone. I would have called it something else. But the idea of media sets is you're specifying the actual physical targeted location as to where you're putting stuff, right? So think about, you're not going to back up to a DVD, but DVD is media, a hard drive is media, files in the cloud are media. So it's where it's really going. And then your backup sets are the collection of databases and transaction logs, the actual stuff from SQL that you're pulling out and you're putting on these media sets. And then we're gonna talk about doing backups. I'll show you how to do backups. You can do your backups from the GUI and from SQL Transact code, so both ways. Backing up the transaction logs. And then yesterday we talked about options for, if you didn't want to back up the entire database, you just want to back up chunks of it. One of the options is to do a partial backup or identify key files and tables in your database and back those up. So that's what backing up partial and file groups are. And then my demo. So you will see me playing with the GUI, the SSMS and the demos. One thing I'll draw to your attention, when you go into the GUI and you start go to a database, say I want to do a task. Let's do a backup task, and then you got the window where you can start filling in the data. Don't press OK at the bottom until you've gone to each one of these tabs, because if you fill in the general information and press OK, it's going to start cranking out a backup right away, and you're going, oh, I'm not done yet. So it's a little counterintuitive, from my opinion, but you have to jump around between the general, the media, and the backup options, configure all those 3 zones, and then press the OK button. And from a SQL command type scenario, here's an example of the transact statement you could use, right? Backup, what am I doing? Full database, transaction log only. What's the name of the database that I care about? Okay, so again, database name like AdventureWorks. Backup to, right? And you can specify the location. When you create your backup device, the backup device is going to have something like, for example, a path name, d:/. I'll also give you a warning. If anytime during your labs it tells you to back up to a location, and you're going to be doing it to a hard drive, if the folder doesn't exist already, the backup will complain. So you may have to step out, go to the drive you're backing up to, make the folder called backups or whatever they're telling you, and then go back to the exercise. Okay, and then general options, right? Backup device. So we're going to see later on when I pull up some of the SQL code, you get to see that stuff in details. So media sets and backup sets. So the media set, like I said, 1 or more disk backup devices. So you could, in fact, have backups going to D drive in a particular location, E drive in a particular location. So you can have multiple chunks. If you have more than 1 media device included in the backup set, or the media set, when you go to do your backup, that data is going to be striped across those multiple devices. So you can pull in more locations. Again, since it's going to be striped, it's just similar in nature to striping a RAID array. You're going to get better performance because those locations are all sharing the load. Will be most effective if the locations are on separate physical drives, because then the actual drive hardware will be able to do the read and writes. If you just stripe it across different files on the exact same hard drive, then you're not going to get any kind of bump in actual performance. So the media targets where it's going to go, and the backup set is going to define what it is you are putting in there. The backup sets are written to the media sets. A backup set could be a brand new backup set that you make for the first time. So for example, the very first full backup that you do, then the next time you come back to do an incremental backup, you can point that to the exact same backup set. So you can think of the backup set as a storage location, and every time you go to it, that storage location or that file was going to grow. And the first time the file may be large because it's a full backup, and the next time it's incremental, but that one backup set, all that information is contained there. Who keeps bedinking? Stop bedinking. Right. When you create the media sets, right, in the backup environment, format will actually go and overwrite the existing media set. So it will go and wipe it and clean it. There is an init command, right, that will overwrite the backup sets and perform some initialization. If you do a format, then you're effectively, and you're pointing to a location that you're already using, that's going to wipe it. Luckily, the defaults are don't format and don't initialize, because most often what we do is we pick a target location. We want this thing going to d:/backups, right, adventureworks.back, and we just want that thing to grow every time. But if you decide to format it, you will actually wipe out that storage location. Doop. Okay, bear with me here. Meetings. All right. Let's see. If I move file, right. So what are our options? Full backup. So it's going to do the entire database and the active portion of log. What log are they talking about? They're talking about the transaction log. So it'll get everything that's currently there. If you are starting up a new backup set, your very first backup will be full because you want everything. And then after that, you can choose to do a differential backup. This is very much like Server 2012 when you use just the Windows backup feature. The differential backup, when you run it, and you'll typically probably put that in the exact same spot, right? If you look at the example here, the backup's going to this file. This differential is going to the exact same file. So this file is going to grow. If you did another full backup, that file would like grow twice as large, but because you're doing a differential, it's only going to put what's changed there. So it'll increase in a smaller fashion. Again, this is the SQL that will do it, right? Since this maybe is the very first backup, this SQL command is doing an initialization because it wants to get the file in place and set up all the management data. This one, because it's tagging back onto an existing file, it's not going to do the init because it doesn't want to screw up the management data. The differential backup, it's arguably interesting. SQL basically keeps a map of what has changed. So you can think of the database file as being, one large square, and that square busted into many tiny squares, and those tiny squares represent chunks of data that changed in the overall database. So whenever somebody modifies, say, a record that's over here, SQL will keep sort of a bitmap of what's changed, and it'll say that changed, that changed, that changed, that changed, that changed. So it's a little picture of what changed in the database. So when it's time for a differential looks at the bitmap and says, okay, what changed? This record, that record. So it pulls it out that way, right? If it didn't do it that way, the option would have to be, I want to do differential. And it would have to scan through and compare two backups and figure out what changed since last times. So cleverly, they actually tag it in this bitmap. So that's how the differential works. Let me see here. Chat. Oh, one of the things about backups, okay, it didn't show up in the slides, but it's in the text. You fire up a backup's cranking along. The backup process does not usually stop people from using the database. So that's good news. If you need to back up the company database, it would really suck if everybody had to wait for yesterday's example, right? Backing up that 20 gigabit marketing database up to the cloud took over 3 hours or something, right? So it would really suck if the company had to be offline for 3 hours. So as you're backing up, people can still keep making changes. When the backup gets to the very end and it's almost done, it says, okay, what changed since when I started? And it'll actually apply the transaction logs to its backup. So a completed backup should be a representation of almost exactly what the database looked like at the time of completion of the backup, not a copy of what it looked like when you started it. So that's another clever thing. And what doop? The net wonk. Okay. So besides full, backing up the entire database, we could back up just the transaction logs. Part of recall the transaction logs yesterday. So it's a log file or multiple log files that keep track of all the reads and writes and deletes that should happen. After it goes to do the backup of the transaction log, it says, okay, I just backed this up. What do the logs look like? Oh, the top part of that file has already been written, so we don't need it. Truncate, toss away. So the backup process by default will do a little bit of housekeeping and clean up your transaction logs unless you tell it not to touch that. There's the code you can do it with. And again, notice here that this is going to this location. So that one file could have a full backup in it. It could have an incremental backup in it. You can come back later and start slamming transaction logs so that one entity can contain multiple items in it. Yesterday, we talked about doing a tail log backup. So the idea is you're about to restore your database because there's a problem. The database has probably been running this time. So you need to make sure that you grab your current existing transaction logs just in case you have to reapply them, because if you're restoring a backup and that backup happened from before, and you're lucky enough to have transaction log backups, what about the transactions that are currently sitting there that haven't been applied? So this is the tail log backup. And typically you should do one of those before you do a restore. There's some options here. So sometimes when you're applying, especially a tail log backup, say the server crashed. So the server crashed and maybe some of the transaction logs are corrupted. The server crashed and maybe some of the database files are corrupted. If SQL is going around cranking, reading stuff, and it sees things it doesn't understand, it could in fact pause the entire restore process because it went, wait a minute, this doesn't make any sense. Continue on error basically says, yeah, don't stop. I anticipate there's going to be things that are completely garbled, so go ahead and do it anyway. So that's what the continue on error will let you do. Yes. So since you can back up transaction logs, so you back up the transaction logs for Tuesday, for Wednesday, for Thursday, and then you need to go back and something happens, so you need to restore the entire database. You need a complete chain of each of those transaction logs. When you do a restore, you're typically telling it, pull it from this particular file, which would be like backups aw.back, and restore them. If for some reason Wednesday's transaction logs weren't there, it is going to fail because it said, listen, I can't automatically do a full restore for you because I got to Wednesday and there was nothing there. What happened, boss? So it's important to keep a consistent full chain of all your transaction logs. And when I say you, I mean the backup process, and I also mean whoever's in charge of performing these backups. You need to make sure it's done on a regular basis. Partial backup. So I don't want to do everything. I just want to do the important stuff. So there is the primary file group. So SQL keeps files and databases of its own, the master database, parts of the schema. So the primary file group is effectively all the management data that keeps the database sane. So partial backup will save all those. If things are missing, such as the master database, then SQL won't even run. If there is no temp database for Scratchpad, right, it will create a brand new fresh one. So there are situations where if you're really, really unlucky, the server goes down and crashes, all your data is fine, but the primary file group, like the master database and all that management stuff, got whacked. So your data is there and it wants to be used, but SQL can't run because all of its record keeping and management stuff is gone. And read-write file groups could be a set of files that you picked and choose from the database. Yesterday I talked about creating a file group for backup. That's all the engineering data, etc. If your database is really huge, then just backing up specific files and file groups, right, will be faster than doing the whole friggin' database. So in this example here, it is doing all the read-write file groups in the system, and it's putting it into this target here, large read-write backup, read-write.back. And again, file groups, if you have the file groups you created, you can specify the file group, right, and put that there. And again, these are going to be two separate files that it is targeting. Okay, so let me show you the GUI portion of doing a backup here. So I'm going to stop sharing that. I'm going to start sharing Hyper-V. Oh wait, ooh, I've already got that going. Bam. Put that over here. over here. So I've already loaded up the demo database for this demo. There's our AdventureWorks. Yeah, I pulled all that stuff in. I logged into the MySQL. Here's the AdventureWorks. So from the GUI, if you want to do a backup, you right-click on the database you want to do. You choose tasks, and one of the tasks is backup. Sorry, I'm trying to move things out of the way here because I've got all of our Zoom stuff running. So there's the backup page. So when I mentioned earlier, as you're specifying the entries in here, don't friggin' click that until you're done. So there's general stuff you're going to do. There's media options you're going to do. There's backup options you got to do. When you got all those specified, then you go ahead and click OK, and it's going to crank the backup. So on our general page, there's our database. Our backup is full. Right? We could do a differential if we didn't want the whole thing. Yesterday, we talked about making copies of the database. So say you wanted to pull it over to another server for test purposes. There's how you could do that. You could pick and choose if you're doing the database, or pick and choose if you want to do file groups. And down here is where you can specify the destinations. You have the ability to remove and add and specify, right? So I've got one I was playing with here before. I'm going to take that off the list. Then I'm going to add a new target location. You could browse to find it, or you could enter in the path name here if you're confident. So I don't know, maybe I'm confident. You can go on /demo file /auto6. If it's not there, it's going to scream at me. Demo /. All right, so far so good. So now we're going to move on to media options. We could create a new media set. We could override all backups, etc. here. There are some things you can do. Later on in the chapter, we talk about how to verify that your backup was good. You could actually turn this on right now, and when it finished the backup, it would double check and say, yeah, looks good. There's that continue on error. If you're making a backup and you know your database is corrupted, I don't care, just do it anyway. So in this one here, to append to an existing, right. All right, so back up to the existing media set and append. So that's the default. So the idea here is that you did a full backup. If you come back later and do an incremental, it's going to remember where you did the first backup to and assume that every time you back up this particular database, you want it to go to the same spot, the same file, and just keep growing that backup entity. Yesterday, I talked about backing up your backups. So this will be that scenario. You keep growing your backup, and then you want to make sure that wherever that exists, you may have a secondary process, not a SQL Server backup, but maybe just a Windows Server backup. And Windows Server backup is cloning your backups folder to put it somewhere else. So now you have the ability to recover your backups in the events that one of your .backs got destroyed. So added that, backup, all right. Backup options. You can set expiration dates. So if you create backups, right, and you have a automated process that does things so often, right, you can say this is no longer good. 0 days means it never expires. Some options we'll see later on in a future demo, but we can choose to compress these things and make them smaller. And can't do it yet, but you can actually encrypt the backup. And there's these special rules that if you want to do encryption, then on that previous page, you have to basically create a brand new media set, and then it will let you do the encryption. Executing. So this will generate our first backup, and it should show up in that folder I targeted. And we'll go back and we'll see what the size of it is. Do I have any coffee left? Sadly, no. All right, potentially that's good news. I'm going to wander over to the folder where it's supposed to go and see what we got. So this was D, demo files, mod 6. And AW back, timestamp. Okay, yeah, so that's Pacific Coast time. But there it is. So add 3, 839 backup. Right, there's its size. So it made that backup file. So another backup. And this time, let's not do. Is everybody still with me?
Yep, I'm here.
Still here.
Okay, so, okay, sorry. I just freaked out a bit because I looked and I saw that the AdventureWorks machine had no internet access. I'm like, what? It's because I got my VM full screen. So, okie dokie. Panic removed. Okay, so we're going to here. Oh, I got to change some stuff first. Pardon me. So the idea with a differential backup is that it's going to only save that part that is changed in the database. So I need to go and find this little SQL script that's going to touch the database. Okay, and it's the update prices, right? Yeah, there it is. Okay, so it just changed 504 entries. So now the database is in a different state than it was before. So we can go back over here. We can go back to tasks. We can do a backup. We're going to do a differential. Again, don't click OK yet. You want to go and double check your various media options. Okay, got that. We're still pointing to the same location, so that's down here. Right? So we'll leave it there because we want to take this differential. We want to put it in the same spot because that backup file is going to grow. Append to existing selected. Okay, so media options. All right, so here, append to the existing backup set. So that means it's going to run this and slam it into the same file, allow it to grow. And inside of our backup options, what's here? Right. So we can actually name this. So this isn't going to change the name of the file. This is going to change the name of this backup that's placed into the file. So we can tag this. So this part we do want to change. Okay, I'm going to call it differential database backups, right? And the other one is scripts drop down. There it is. So one of the interesting things you can do, I guess arguably interesting, is that when you are running things from the GUI, you could tell the GUI to, hey, do you want to actually make me a script of all the stuff you're doing in the background? So when you're running this through the GUI, could you make the transact SQL statements for me? That would be a quick and dirty way. If you were tasked to create a backup process and the programming guys say, hey, it'd be really handy if we could have that script because we're going to put it in our program, then you could go here, do it from the GUI and actually generate the script and then save the file to them. So in this case, we're going to script action to a new query window, but we could have put it in a file. Right, so it's doing a little bit of extra work. Okay, so we did that, we did that, we did that, gave it a different name. Now we're going to say okay, and now it's going to crank it out. Okay, it says it's successful. There is the SQL query that actually did it. So backup database to disk, there's a target with differential, etc. So if you wanted to, you could save that to a file, right? Use it later. And if we go back here, the file grew. But it didn't double, right? It grew slightly. So that is the actual container of the full backup and plus that differential. All right, stop sharing that. Boop. Start sharing PowerPoints again. Share. All right, can you guys see my PowerPoints?
Yep, I see them.
Thank you.
Yes.
Great. Hello. Oh, blank slide, blank slide. All right, now it's the management conversation. So we've made backups. What can we do to control them, right? Make sure they're usable, make sure things are organized. Part of the conversation will be deciding how long you're keeping them. So retention policy. Do we keep all of our backups for an entire year? Do we keep backups for a month? If we're keeping them, then where are we keeping them? And also the whole testing policy. I mentioned before, it really sucks if you go to recover a backup and your backup is no good. Then you're out of luck. Options for making sure your backup is correct, its integrity. And then if you're curious as to what's been happening with your backup, so you can actually view the history, retrieving backup metadata, right? So remember, metadata means data about data. So when you do a full backup, there's some management data or metadata that says, oh, here's a full backup. When you do a differential backup, there's some metadata that says, okay, this file contains the full backup on such and such a date and the differential. So all that metadata is the accounting information about what's inside that file. And then verifying backups. You want to make sure that the backup you have isn't corrupted or the backup that you just did is correct. So retention, again, how long you keep these backups. There's multiple actors that can determine that. You may have corporate policies that spell out really well. You know, all backups are kept for blah, blah, and stored over here. There may not be corporate policies, but maybe you take it onto yourself and say, okay, somebody's going to come back and ask me for this stuff. So there'll be rules that determine it. But you could also be governed by governmental regulations that say, you know, thou shalt keep this data. Imagine GDRP type scenarios. It's almost like a double-edged sword. There could be rules that say you can't keep people's personal information forever, so you got to nuke that. But there also could be, well, you got to keep it at least for this long because we're going to come back and check your databases to make sure you're following the rules that mean you don't have personal information in it. So you got to find the retention strategy. The most important thing about backup retention from your perspective is the ability to retrieve the data and bring the system back online. Part of the things you have to think about is what are the combination of backups that you need for database recovery. I'm backing up the transaction logs. I did a full backup way back when. I've only been doing incrementals after that. So therefore, if I'm going to recover, I got to make sure I can get the full one from somewhere. I got to make sure I can get all the transaction logs and all the incrementals. If you're doing full backup, go ahead.
Is that the reason why a lot of companies stay with a certain OS instead of upgrading to like the later versions? Because all their backups are to that certain version. So there's no point.
Yes, well, there's that, but also a lot of the aspect, yesterday's conversation when it talked about verification is that you've been making backups like nobody's business and everything seems to work great because you're doing them on server 47. And then you go to server 48 and you try to recover those backups and it doesn't work. Yeah, because server 48 doesn't support the device that you're backing up to. Yeah. So there are a lot of companies that are stuck in the way they do backups because they're completely dependent upon their environment. And if they change it, if they change it, things break. I'm sure you guys remember good old Alan, and that Alan apparently was a data backup expert for companies
Yep.
from way back when, and he had conversations about a buddy of his that's busier than you can imagine, because there's all kinds of companies out there that need his expertise because their backups are being done using System X, and the company that supports System X no longer exists. So there are scenarios like that where you just got to keep doing it because all your eggs are in that basket. Now, gracefully, they should be planning another backup strategy, right? And once they've relied upon that, legacy the old one. But archival requirements. Sure, you got to keep your backups, but you don't want to keep them on your backup server because your backup server will get full. So therefore, every year we grab the old backups, archive them, put them on some kind of other media, and shelve them somewhere else. Synchronization with database checks. If somebody does a scan and finds out that this one particular table is corrupted, and you go back and you look and you realize this table has been corrupted for a very long time, your choices are accept the fact that your backups of that table are crap, or you can actually take your backups, load them up as a copy database, correct that, apply the transactions, and then save it back again. So there are some house cleaning things you might have to do to retroactively fix errors. We've talked about how things such as an Active Directory, right? Your NTDS database, your DNS, all those things are really useful data stores. And if somebody can get their hands on them, they can wreak havoc. Same thing with your corporate data. So you need to have a secure location to store your backups. We're going to talk about encryption later on. So that's one of our options to make sure that if our backups fall into the wrong hands, they actually can't crack them open and look at them unless they have the appropriate certificate, right? i.e. public-private key pair for encoding, decoding to see it. Do we have the hardware for storing backups? So kind of like what Eric and I just talked about. We get all this data. Do we actually have the box that lets us read the data and put it back on the machine? And is this backup actually complete? Does it have everything in place? I've already got a bar in the way. Oops, excuse me. So options for making sure that your backup is reliable, has integrity. So multiple copies of it. Mirrored media sets. You can think of this as creating a mirrored RAID array of hard drives, except this isn't at the hard drive level. This is at the backup set level for your media. So you can have up to 4 different spots where your backups are going to. And those 4 spots, since they're media, could be different locations. So I'm backing up to server 1, 2, 3, and 4. Server 1 goes kablowy, right? You can rebuild the data using the other ones. And yeah, mirrors require the same number of backup devices. So it has to be a one-to-one mapping. And of course, you can't do this unless you pay for the most feature-rich, expensive version of SQL Server, right? This is an enterprise type thing. So it only works in the enterprise edition. Recall the concept of checksums. Okay, let's rewind the tape back to layer 2, right? Recall that layer 2 frames have a checksum at the end of them, and the checksum is basically almost like a hash of the data, and the checksum says, okay, based upon what's before, there's 10, 10, 10, 10. This number is the resulting checksum. If you go back and look at the data and run a new checksum on it, and suddenly the checksum you had stored doesn't match the checksum that reflects the contents of the data, that will be an indication that something's gone wrong, right? i.e. the file got corrupted. So you do have the option of creating a quick and dirty checksum for your backups, so that when you go to restore the backup, you can say, please verify the checksum I have stored for this, and create a brand new checksum from this database, and let me know if they match. And if they don't match, you go, frig, something happened to my backup. When you want to check a backup and see if it's actually going to work, you can use a restore with verify only, which means that it goes through the entire process of pretending to restore, and you can basically see at the end of it, it'll tell you, everything's successful. So you would know that if I wanted to restore this backup, then it would probably work. If that fails, then that gives you an indication that something's wrong. Recall that if you have a full backup and an incremental backup and all these transaction logs, one of the things that could cause the failure is a missing component. I've got the full, I've got the transaction logs. Where the heck's the incremental? So it may not fail because there's data corruption. It may fail because you haven't got all the pieces in place, which means you go and find all your components, say, okay, now I've got them, do the restore. Combining verification with checksum is good because it'll make sure that the backup was not corrupted, and then attempt to do the restore and let you know if it would have worked. Some of the things that bite people when you go to do a restore and you have your testing policies, and it's not on this slide, this is in the textbook, not enough copies of the backup. I've worked at places where we make a backup to the file server, we make a backup to a separate storage device. This company didn't have cloud at that time, so the separate storage device would actually leave the building at the end of the workday and go home with some designated person. So maybe the IT guy would take it home. Perhaps it would, go home with the manager, but multiple copies. So in the event that the company burnt down, you still have a backup offsite. So insufficient copies, insufficient data on the backup. You go and find a backup file. You think all your files are there. Nope, somebody changed the backup script. Oh, somebody forgot to change the backup script to add that new database. We forgot we made an AdventureWorks 2 database that was part of this other project. Frig, we've only been backing up the original one. And then unreadable, corrupted, unavailable hardware to actually restore the backup, old hardware, right? So got to watch all those things. You've been running backups, you want to see what's inside that particular backup set. What's the metadata that's in there? So you can actually look at the backup history, which you can do from the GUI as well. Here is an example of SQL code that you can throw down. There's the master database. So this is a SQL query that's going to look inside the backup activity of tables inside the MSDB. It's pulling in from a couple spots. It's pulling in from the backup set. Remember, the DBO is an object that represents the entire database. So that is internal management information. So it's pulling in the backup set table in the backup media family. It's assigning it sort of to a temporary pointer called BS, another one called MF. And then wherever the backup set media set ID actually equals the media set ID for the MF from the backup media family, and where the database name is AdventureWorks, right? Order this by the backup finish date, give me the description, right? So that query will reach in and give you a history report of the backup activities that's been going on in the server. And inside the GUI, the SSMS, you can go and look at basic reports and checks to see what's going on. So are you going to do it via code? Or are you going to do it via the GUI interface? If you wanted to look into a backup, right, and retrieve its metadata. So again, what is metadata? That's the management stuff. What's in this file? What was done when? If you want to look at the overall high-level label for it, right? So it's going to return the information about the backup media on this particular device. If you want to see the header, it's going to return the header for all the backup sets. And if you want to see a list of the files that are contained in the backup set, right, you can use restore file list only. Again, you can generate these reports from the GUI as well, besides SQL. Okay. Right, the textbook talks about some other things you can do. So if you decide you need to go in and do some housekeeping, since the SQL Server database is keeping track of this management stuff, all the history of the backups will be recorded since the beginning of time. So if you go and say, okay, I don't really need to know the backup history from, from like 10 years ago. There's commands you can execute that will actually remove that data. It's not going to remove the backup. The backup probably still lives somewhere, but it's going to get rid of the history information from the database table. All right, so let's jump into the demo. Going to stop sharing that. I'm going to start sharing this guy. And sure. So there's our AdventureWorks. Okay. Then we have some reports. You can build your own reports. That's what custom's all about. There's a bunch of standard ones built in here. So there's, as you can see, there's backup and restore events. There's other reports in here that we haven't talked about yet. Pull that up. All right, so what do we got here? Successful backup operations. Okay, so yeah, it looks like today's date. So here's the things that went on. We did a differential, right? Full backup, full backup, full backups. Some of these full backups was me messing around, making sure files were being created earlier before I saw you guys. Okay, device type. Okay, so we can expand this, and so that's physically where it went. So this backup was a differential, right? Here's what it was called. It was done by the student. It was a full backup, and here's where it actually went. So you can go through and look at it. No errors, successful restores, right? No restores yet. Verifying backups, open. So this is a little more elaborate than what we saw back in the textbook, but it's doing something similar. It is pulling up information from the backup set of the DBO. And it's going to run and give us a history report. Gonna find the stored procedure SE. Nice. Who did I miss?
Forgot the U.
Thank you very much. I'm a programmer. I was suddenly looking for the object called SE. All right. Thanks, man. All right. So pulling it with SQL code. Database name, log test. That was me messing around before. All right. Database, physical device name. Oh, this went to Rob test. That was me messing around. Here's what we did before, our AW ones. All right. So there's some info. Let me see here. Oh, this part of the SQL code is actually specifying I only want to see stuff for the last 30 days. Backup start date, get date minus 30. So if you're running this code and you want to change it and see like 2 months of information, right? So you can basically vary this calculation. So that's what that's all about. Okay, so we're going to talk about restore header only. Right, so here's some of the header information. All right, so there's who run it. Okay, so again, it's reaching in and pulling back metadata information from inside the backup that we made. Okay. So list of files involved. Okay, so a whole bunch of data in here if ever needed to troubleshoot down to a lower level. GUIDs, just like we saw in Server 2012, right? Globally unique identifiers. So there could be scenarios where you're hunting through a whole bunch of backups and you're trying to find this identifier because that identifier points to that particular part of the differential and it's missing. So there's lots of data in here inside the metadata that you could use if you're stuck doing a major search mission. Okay. And if you wanted to just pretend to do a restore, right, to verify whether or not it would work. Okay. So it's basically saying, yep, I didn't find any errors. So this was a verify only. So you can have a level of confidence that whatever is inside aw.back could be resurrected if you needed it. All right. Let me find my Zoom. Burp. Stop sharing that. Move this around. I need more monitors. Share. PowerPoint.
Rob, is there anybody at the school who can get my extra monitor cable that I can set up a second monitor? It just saves me having to buy another one.
So I'm not sure who Nicole has designated, but Henry's directive, I think I told you guys yesterday, right, was that if we need stuff out of the school, then there's one person who could fetch and make it available. So I would reach out to Nicole or email me later to remind me. And so if anybody has requirements, I can't promise the world. I'm fairly confident that the school is going to do all they can to help you out. So maybe if you need a few bits and pieces, fire me an email. I will see how management responds, and then maybe we could, coordinate some kind of delivery mechanism. But let me know, okay?
Might be an option if anybody else needs maybe a spare monitor to be able to do these VMs or something at home from their laptop. We could kind of get them all at once.
Yeah, that's what I was thinking about. It'd be really handy to have extra monitors. So I can't promise, but feel free to, when we're done all this, send me an email and saying, hey, here's a list of stuff, and be reasonable, right? Extra monitor cable would make my life easier. And then I'll present this package up to management and say, okay, we want to do this. I'm about 90% sure that they'd say, yeah, that makes sense. So
You want like one email? I can get everybody to email me and I can then send you a finalized list, or do you want the
individual, well, I think it's 12, but no, everybody individually email me and then I'll collate the data, because then I can basically have leverage to say, listen, I got an email from everybody. Everybody wants this, right? As opposed to a whole classroom.
Downstairs.
Yeah, exactly. So send me an email about stuff you want. An extra monitor, right? Sounds reasonable. They're in our classroom to begin with, and there's nobody there. So what's the big deal, right? So, all right, you guys can see my PowerPoint.
Yep, I'm good.
Okay, thank you. Okay, so some of the advanced options. So copy only backups, making a clone for testing purposes, making a clone for research purposes, compressing the backups. So making the database substantially smaller. One of the advantages here is that if you compress the database and the database has to be pulled down from the cloud in order to be restored, you can pull it down a lot faster, and something like that might actually help your recovery time objective. So maybe one of our options from the Goofy lab yesterday would be to actually have compressed that puppy. And if you pull down the compressed file, hey, guess what? I can pull that down now in way under 3 hours or 2 hours. Thank you very much. I don't have to jump through hoops now. And also on top of compression, right, there's the ability to encrypt the backup. Encryption is only going to work if you have an encryption key on the server, corresponding certificate. You guys remember how encryption works, right? You can't decrypt it unless you've got that key. That being said, if you have an encrypted database in SQL Server and you want to move that database to another server to be used, you have to also copy the key over to that other server. So key distribution becomes a possible item. Also, just like EFS way back in the days of A+, if you use encrypted file system locally on your machine and a certificate and a key is created, if you lose said key, then you can't get your own friggin' data. Well, same kind of idea here. If you're encrypting your files, you better make sure you're backing up and securing your keys and certificates, right? So that you can open your own data. So now you have more stuff you have to back up. If you are doing a backup and you did the backup that wasn't a copy only, then you'd be backing up probably to the same aw.back file, which means it's going to be added to the list of things that were in there, which means it's going to affect the metadata, which means that now if you want to restore things, you've got 1, 2, 3, 4, and this fifth one to worry about. Well, a copy doesn't actually affect your original backup, right? It doesn't become part of your official backup. It's just a copy you're making. If you do a copy only and you're just copying the transaction logs, it's not going to truncate the log. What are they talking about? I don't know, half an hour ago, we mentioned that if you do a transaction log backup, part of the cleanup that SQL Server does, it says, oh, you're backing these things up. Great. I'm going to throw out crap I don't need anymore. If it's a copy only, it's not going to touch that because you're not really backing up. You're just making a clone. Copy only, right, doesn't affect the differential database. So remember, the differentials uses that bitmap thing I talked about, and it has like a bitmap, and it says, oh, that changed, that changed, that changed. Just because you're making a copy-only backup, you're not affecting the reality of your overall backup process, so it doesn't mess with that. How could you do this? There's the SQL code at the bottom of the slide, right? Do that, put it here, okay? Of course, you're going to give it a different file name because you're trying to put it in a different spot, and this is copy only, right? So don't concern yourself with modifying, the metadata. And I'm actually talking to the SQL Server, not you guys. Compressing reduces the size of the backup. Again, reduces the I/O requirements. What? Well, read and writes, pulling it over a network, right? How long it takes to restore, that gets a lot smaller. But since it is compressed, that means that it has to be decompressed, which means an algorithm is running, which means the computer is doing work, which means the CPU usage goes up. So it will increase the speed of your backup and restores, but it's going to increase the load on the computer that you're doing it on. So you need to keep that in mind because if for some reason your SQL Server is at a threshold, compression could in fact break it. And if it's at some kind of medium threshold, restore processes could slow down everybody's interaction with your overall server. With if you're doing compressing, you can't mix things, so you can't have uncompressed backups and compressed backups sharing the same media. The built-in Windows backup feature, you can't integrate that if you're compressing with SQL because SQL is doing it its own way. And older versions of SQL have no freaking idea how this works, so you can't restore it to pre-2008 versions of SQL. Okay. Before I demonstrate, let me see if there's anything interesting it said. Performance, blah, blah. Oh, okay, cool. Okay, I'll switch over to my Hyper-V in just a second. Stop sharing that. Start sharing this. That's you. Excuse me. You guys can see my SQL machine?
Yep, I can see it.
Thank you. Okay, so we're gonna do another backup, but this time we're gonna do a compressed backup. And remember, don't freaking click this OK till you've gone to all these tabs. VentureWorks, full backup, right? Destination, okay, so we're not gonna put it over top of our other one. We're gonna nuke it. We're gonna add a new spot. Okay, there's my new target. Media options. Zoop. All right, so default is still append, but that file name I gave before didn't exist. So it's going to create it as opposed to append. So append will do both, creating the fresh one for the first time, right? Okay, again, when this gets created inside the metadata, what do we want to name it? So we're going to call it compressed. Okay. And now when it comes to compression, we can pick and choose what we want. So we're going to say forcibly compress the backup. Okay. Now it should be able to crank. And if I targeted that correctly, it should be in the same folder as the one we made before that was not compressed, in which case we can look at the two files and the compressed one will be smaller. Success. So if you trust the compression algorithm, that's all the same data that was in that database, just in a much smaller format. So that's how we can do the compression, okay? And let's see here. Okay, I stop sharing that. Do-si-do. I go like this. Have a nice day. We go over here. Meanwhile, back at the ranch. Bing bong. I'm wondering if that's my incoming emails. It's making that giant friggin' bing bong noise. I'll have to check later to see if it is. Okay, and then related, right, to compressing is encrypting. If you're going to do this, you have to have a database master key for the SQL instance. When you have the master key, you're going to create a certificate, and the certificate is going to have an asymmetric key. So remember, asymmetric means public-private, right? Two ends. And then once you decide to do the backup, you specify encryption, and then what algorithm you want to use, and you have a few options. Here's an example in SQL code. So we're going to do the backup, right? We're going to format. So we're actually going to wipe this file. That's a typo. That better not be a comma. It's going to be a dot in that spot. Format, initialize the encryption algorithm. And we're going to use the following server certificate, right? In this case, it's the backup cert that was created. And of course, we have to create that in order for it to work. So I'm going to stop sharing this. Jump back to Hyper-V. Nope, not Hyper-V. The actual SQL machine. Okay. So I've already done this. We're going to be throwing these backups into different spots. Remember I mentioned before, if you tell it to target somewhere and it doesn't exist, it has problems. So I previously made this folder called backups, right, on the D drive. As long as I don't make any typos, it should be all right. Now the other option is I need to make the corresponding encryption keys. And then luckily, the setup files, all right. Dmod 6 setup files. All right, so we have a chunk of SQL code that'll actually generate the key set that we need. So it's going to make the master key, right? Going to back it up, so we have a clone of it. Remember I mentioned before, if you lose your keys, that's really bad. Then it's going to make a certificate that we can use, and then correspondingly, it's going to back up that certificate. Notice that it's backing it up, and it's locking it down with a password. So yeah, so now we got keys, certificates, and now you got a password you got to remember too, because if you actually want to pull that out and see what's inside of it, it's going to be password protected. All right. Okay, it is using by default this algorithm, right? So AES 256, there's our creation date. So that's handy. Let's back it up. Okay, so we got a clone of it. So we got the key, and a certificate is going to be created, and that certificate is going to use the master key that we just created for the server instance. So create the certificate, and we're going to do our due diligence, and we're going to back it up so we have a copy in case things go sideways. All right, now we're going to do a backup, and this time we're going to go for encryption. All right, so we're doing a full backup, right? But we're going to get rid of this, and we're going to put this in a different spot because we don't want to nuke our compressed one. So we remove it. We add a new one. Colon slash. I'm assuming this is going to the backups folder that we just made. AW dash. Get fingers in the right spot. Yeah, our target. Media options. All right. So here's one of the gotchas with doing an encrypted backup. Every time you do an encrypted backup, you have to back up to a new media set and erase all existing backup sets. It's just the rule. What are we going to call this new media set? We're going to call it encrypted backup. Okay, and there's some other options down here where we can do the old verify. So we're going to do a combo here. We're going to compress it and encrypt it. Here's our algorithm, right? We can pick and choose the one that we want. So let's be as secure as the other defaults were. And this is the certificate that we created earlier. So if we hadn't ran that SQL code that made the master key, that made the certificate, we'd be SOL here because there'd be nothing for us to choose to use as the background. All right, and we're going to do this too. We're going to script this. So when we run this, it's going to keep a track of the script for us so we can look at it later. And we're going to put it to a new query window. Okay, and we're going to let her rip and see how it goes.
And anybody with like a second screen, I got two screens going with Rob playing on the TV, and it's like so much better because you can actually hear it loud. So if you can do that.
Oh, you got me on the TV?
Yeah, I got you two screens so I can do the work
Cool.
on my laptop and then got you on the TV.
This lab brought to you by Great Value Water. Probably not even water, but hey, who cares? There's a commercial. All right. So here's the SQL that was used to actually run that. So again, you could save this file off if you wanted to run this a la SQL instead of doing it through the GUI in the future. And meanwhile, back at the ranch, go to the D drive, backups, wham, okay. So there's our AW encrypt backup, okay? And we compressed it at the same time. So notice here, it's, if you recall, that's the same size that the one was that I'd made back in the other folder. Yay, okay, good timing. So that's the end of this module. Almost 9:30, so let's take our usual 9:30 break, reconvene here at 9:45.